All right. Hello, everyone, wherever you are. I am Josh Grant from Code Intelligence, Dev Relations at Code Intelligence, and thank you for joining. So today we are talking about JavaScript. So we are going to do some fuzz testing in JavaScript. We're going to use Jest as the test framework, and we're going to use Jazzer.js. So Jazzer.js is a fuzzer developed in JavaScript by Code Intelligence. But very smart people here who are very good at fuzz testing and feedback-based fuzzing. So all that lovely technology gets wrapped up in Jazzer.js, and now there's integration with Jest. And so in this, excuse me, a little cold out there. So in this tutorial, in this session, we're going to fuzz a fun function. We're going to start writing a unit test in Jest, and then we're going to show how you can take that unit test and basically copy paste it, make a few tweaks, and then you get a fuzz test. And so you can test your known functionality with a unit test in JavaScript or something else. But then fuzz testing provides you the ability to explore and to find other bugs. So you can find bugs you didn't even think about, security bugs or otherwise. So let's get started. One thing I will say, I will be doing this. It's kind of a live coding or semi-live coding. And I do have a link. My lovely colleague could post that in the chat. If you want to follow along, if you want to take a look, GitHub link there. So, and if not, I can show it as well. So let's get started. This will be, roughly 25 minutes. There'll be some questions at the end. Yeah, definitely feel free. Grab a hot beverage, relax, get out your favorite, text editor, and let's get started. So, there I am. Wrong button, sorry. So we're going to share. So here we are. So I'm going to use Visual Studio Code. And so here I have this single function. So I have this function. It's called Explore Me. And I'm not going to show you the body of it. It's not relevant at this point, but imagine you have this function somewhere in your code base, or you wrote it, someone else wrote it, one of your colleagues. If you're an open source, it was maybe contributed before you joined the project or something like this. And we're going to test this function. So first we're going to write a unit test. So what could this function do? Well, I'm going to go over to here. So I have this. So I start with my basic. I'm going to use Jest, and I'm going to start with a basic unit test or test style in JavaScript. So here I have my describe block. I have a single describe block in my test.js file, good practice. And in this describe block, I want to describe my test suite, or like my, whatever I want to call it. I'm just going to call it my test suite. And then for a given test case, I can provide an it statement. So its are kind of like test cases. You can do lots of different things with it statements. You can think of them as like an at test if you're from Java, or I guess if you're from Java, that's the best comparison. So this is a single test case. So I'm going to test my function. I'm going to call it my explore me. And I'm just going to call this. Okay. That nice arrow notation. Okay, so this is where I start with my test case. Now, as I said, I don't really want to get into what the details of this are, because we're going to explore this function. So, but what I do know, or what I can tell you about it, is that it does return some kind of length. So if I pass in some data, so it does take a buffer. So a buffer is a data type in JavaScript, which kind of just takes up a certain known length of bytes or something like this. So it could be a string, it could be a value, or so it could be a number value, could be a string, could be, I guess, something else. But, let's just think of strings. Strings are nice and easy. So one thing I know about this function is, or that I think I know about this function, is that if I pass in a string, so first I'm going to actually get this thing. And I'm going to use, because I'm old school, I'm going to use declare statement. Of course, you could use import statements, or if you're in TypeScript, use whatever TypeScript does, but I'm old school, so I'm just going to require this. It's perfectly good for this case. And I'm going to call explore me. So the first thing I'm going to do is I'm just going to pass in a ABC, so a string called this. And I expect the length to be 3, right? There's 3 characters, A, B, C. And, oh, yeah, that's good. So this is it. So this is the first functional test, or the first unit test that I can write. Does this return sort of a happy path? If I give in a string of length 3, do I get the right value? Do I get 3 back? Excuse me just a moment. Okay. All right. Just. Okay. Great. Perfect. Okay. So let's run this function to make sure that this does what I think it's going to do. So first thing I'm going to do is I'm going to go npm. Well, first I could go, let's take a look at my package.json, make sure everything is good here. So under dev dependencies, I have Jest, I have a latest version of Jest. I have some other things here to kind of help with like linting and that kind of stuff. And so for my test, I'm going to run my test using Jest, the Jest runner, and I'm going to match this single file. So this integration test, this could be called anything. I could call it unit test. I could call it functional test. I could use whatever pattern I want. It's a good convention to use .test.js or spec.js to kind of denote tests, or to denote that these are in fact test files. So these are some kind of tests that are going to be executed using Jest or using another runner or something else. So that's all kind of set up and ready to go. So now if I run npm run tests, test runs. Oh, and we're just gonna ignore this other one for a moment. We're just gonna ignore this. Of course, it doesn't go well. Okay, so but this runs and passes. Okay, so and if maybe I can explore this further. I'm just gonna clear that out. Maybe I can explore this further. Maybe I could write like another it. So copy. It's a good practice when you're starting to write tests, unit tests, any sort of automated tests. Copy pasting can be a really good way to get started, just because you want to copy all of the structure. So explore me. So like maybe I want to do something such as single character. Maybe I just want to put that in. I want to just do A, and I expect this to be 1. And I'm actually just going to, I see the problem. Okay, so I'm just going to run this again. I have these 2 tests. And these 2 tests pass and run. Okay, we're just going to ignore this for now. But these 2 run. So already I'm getting some sense of, I have this explore me function. And again, I'm fuzzing a function, but it could be a module, could be a class. But functions, especially in JavaScript, functions are kind of a nice construct to look at. So I'm just looking at this single function. And it looks like if I pass in a string, if I pass in some like list of characters or something like this, I'll get back a length. Okay, so that's looking good. So now let's think about how we might fuzz this, or how we might explore this further. So in these cases, both of these unit tests are things that I thought of. So as the developer, I sat down and said, okay, I want to verify this string should return a value of 3. This character should return a value of 1. This kind of thing. Excuse me. There could be other cases I want to think of. Maybe there's boundary cases, but these are things that I'm thinking about, right? As the developer, I'm thinking of these test cases. The approach of fuzzing is to say, let the fuzzer explore the function itself. So let it sort of generate and execute test cases in order to find interesting test cases or buggy behavior. So how might we do that? Well, the big hint is here. So I've created this integration fuzz.js. So this denotes that this is a fuzz test. It's slightly different path name. And the first thing I'm going to do is I'm just going to copy paste my tests. So step one. So if you're starting with unit tests, and if you aren't, you should. Unit tests are very helpful in JavaScript. They're very helpful just to get a feel for like what your code is doing, what kind of functionality it has. Test-driven development is like a way to build up various constructs and kind of design your code using tests. So you probably have unit tests around. Unit tests should be fast to run. They should be cheap and fast to run. They should be pretty easy to write in general. So they're probably around. So how do we take these nice unit tests that we have and transform them or kind of modify them to make them into fuzz tests? We have a fuzzer, so let's write some code to kind of transform these into fuzz tests. So the first thing I'm going to do is I'm going to copy paste just the whole thing. I'm just going to copy paste my entire describe block with anything that I've imported. Okay, paste, just like this, easy peasy. So I'm still using this target. I'm still using this imported function that I've written. And I'm going to call this, I'm going to give this a slightly different name, my fuzzy tests. And I'm just going to focus on one. So I only really want one test case, if you will. So only one if statement, or it statement, I should say. And I want to call this like initial fuzzy or initial fuzzing, maybe. So in the simplest case, so a good guide for writing code in general is what's the simplest thing that could possibly work. And so in that case, what's the simplest thing I could do? Well, I'm going to call a function. I'm going to call a function, and I just want to verify that it works, that it does what it says on the tin. So I'm going to take this. My first thing I'm going to do is I'm just going to keep this exact assertion. So I'm going to verify that like my explore me returns something that I expect to be 3. I'm just going to keep that as is. In fact, I can get rid of this. I just want to expect that this returns something. Does it return something? Okay. So the next step, so this is just replicating, copy pasting exactly what my unit test was doing. So the next step is let's introduce fuzzing. So I have a fuzzer, and don't want that one. So my fuzzer is Jazzer.js. So I'm using Jest, and it integrates with Jazzer.js. So Jazzer.js can be installed using kind of the conventional way of installing dev dependencies with npm. So install save dev, and it's at Jazzer.js. Jest. I'm going to cheat. You can also put it in your package.json, of course. So under dev dependencies, I have this Jazzer test runner. So here, so I'm going to copy this. Now, in this case, I'm just going to use this directly. But you can also do something like get the latest with like star something. Oh, not pound sign, star, get the latest, or if you have a specific version in mind, you can also get that as well. So I'm going to get that here. So I'm just going to call from npm. I'm going to install it in the conventional way. Oh, and I probably didn't do that correctly. Okay, so I want to do npm install Jest integration. Just down here, Jest runner. That installs perfect. Look, no vulnerabilities. Excellent. So you install this. It's part of your package.json. Okay, but for the purposes of this demo, I'm just going to use this here. So I'm just going to use this local version. But of course, you can get it through npm, kind of conventional. So that's the first step, is getting your fuzzer. The second step is configuring Jest. So Jest is a test runner, and so it will understand describe and it blocks, kind of as I've shown. So the second thing to do is to configure Jest to understand how to execute using Jazzer.js. So there's a bit of configuration here. So under Jest, there are a couple ways you could do this. The way I've set it up is using my package.json. So under package.json, I have Jest configuration. I have a project. And so I have this configuration. So I'm telling Jest, use this configuration, and that's available through the GitHub repo. So use this runner, use the runner that I just installed. You can also like change colors and change display names and that sort of thing, and look for test match. So this is helpful as well. I'm also showing, I'm distinguishing between fuzz tests. So instead of just finding any old spec.js or test.js, I'm saying, okay, look for these, look for tests or look for spec files that have dot or fuzz.js at the end. So I'm kind of separating out my tests, separation of concerns. I have functional unit tests over here, and I have exploratory fuzz tests over here. So we can do that. All right. So now that I have all that configured, and just in case just for completeness, npm install. So that gets everything there. Perfect. Everything's good to go. So I've installed Jazzer.js, an npm dependency in my package.json. I've also configured Jest to use this runner for these specific files. So what do I do? So the good news is this is very easy. So all I need to do is now I'm going to say git fuzz. So now Jest can understand this as a fuzz test. And it's important. What's the other important part of a fuzz test is data. So the fuzz, reminder. So fuzzers both generate test data. So they'll figure out ways to find test data that you can put into your function under test, your method under test, etc. So they generate that test data, but they also execute the tests itself. So that's where your test framework comes in, and that's where the fuzzer comes in. Your fuzzer will also execute and validate what happens with that test data that's generated. So I'm going to use data here, and that's it. I think the linter is not happy with me, so I'm going to disable that. But otherwise, it's good. So this is it. So I've now turned my functional unit test into, and I'll save, very important. And I will change this into a fuzz test. So now, and then I guess last but not least, because I have this data object, I can now pass it into here. So, and as a quick comparison, so in my unit test case, I have fixed data. I just chose a string or I chose a value. In my fuzz test data, or my fuzz test case, I have this data object. So this is what gets generated automatically. And this is where the magic of fuzzing happens. So how do I run this? Well, let's go back, package.json, because I do have a fuzz script. And so again, I'm calling Jest, and I'm looking for a test name with fuzz in it, which is right here. So I'm able to find this describe block and execute the test cases in it. And the last thing I want to point out is this Jazzer fuzz, which I'll get back to in a moment. But that's also an environment variable that you can set. That's helpful and kind of distinguishes between two different use cases for your fuzzer. So let's take a look. Let's run npm run fuzz. Oh, I'll make this a little bigger, actually. Okay, so now this is running. So what's happening? So in the unit test case, and it ran. Look how fast that was. Wasn't it fast and easy? So in the unit test case, it executes the code. I want to say top down, but that's not quite true in JavaScript. But it executes the code in the each it block and test case and executes it and tells you if it passes, fails. Here, the fuzzer is doing a little bit of extra work. So our fuzzer under the hood is coming up with data. The data is, I don't want to say randomly generated, but like a seed is chosen through some method, and then there's some output here. So data is getting generated, and there's some interesting outputs from the fuzzer itself. So this is all from Jazzer.js. So it's running, and then, oh, look at this. And it finds this. It finds an error. So it's able to, without knowing anything about the function, without knowing anything about what the function does, or kind of like any previous knowledge of the function, it's able to find this error state. So it's able to generate this randomly generate this string, this fuzzy string that generates this error state. So that's pretty cool. And then there's some additional output here. So this gives you like the exact at the byte level, like which bytes are actually generated and passed into the fuzzer and into the test method to see what happens. So this is also generated here. So let's go back. Let's take a look. Let's look at this mystery function. So we can finally look into this, and it turns out, look, I was kind of right. So if your length is not 16, it'll return the length, right? Excuse me. Thank you. I apologize for that. So we have this function, and it does actually return a length. So if you pass in some value, it gets converted to a string. But then there's some other cases. There's some other logic. You may have experienced this if you're a professional developer, where there's just some logic. You look at source and you think, wow, why is it doing this? Or like, why was it written this way? Or who wrote this? Or WTF? And that's what's happening here. So here we have a basic function where you return the length of a string, but there are some other exceptional cases, including this very specific case where if you pass in this string, awesome fuzzing with an exclamation mark, you'll get some error. Would you ever have thought to use awesome fuzzing exclamation mark as test data? Maybe not. It's obviously not simple. It's like a longer string, all this kind of thing. But it does show you that like there are some paths in your function that could trigger some exceptional behavior or some kind of bug, some kind of vulnerability. This happens all the time in code bases that are pretty mature. So this is an example of that. And the Jazzer.js fuzzer was able to catch this with minimal intervention. So we started with this unit test, a couple of unit tests even, copy pasted, made a few small changes, introduced a fuzzer mechanism, like how the fuzzer gets called, introduced this data object, and then basically executed the function. So you can do this. So fuzzing. So that's kind of the basic example. So this is the basic example of Jazzer.js. There are some other features that I just want to go over really quickly. So I go back to JSON, or the package JSON, sorry. So Jazzer Fuzz 1. So what is this? So there are two execution modes in Jazzer.js. One is called fuzzing mode, which is what Jazzer Fuzz 1 is. That's where the fuzzer explores the application. So it will just generate data in a very intelligent way in order to find interesting test cases or interesting input cases in order to find bugs. So that's what we just did. This is sort of the fuzz mode where you're exploring your application, trying to find these bugs and these exceptional cases. If you turn this off, or if you set this to 0, this changes the execution style to a regression mode. So regression testing, suppose you found this bug. Now let's go back. Where is it? Suppose you found this bug and you realized, oh, well, this string behavior shouldn't be here. So you just want to remove it, something like this. You want to fix it up. You may want to validate that this behavior does not reappear. You want to verify that this bug does not appear again and regress back. So that's kind of the ideal of regression testing. So what we're going to do, so in this case with Jazzer Fuzz, if you turn this off, Jazzer Fuzz will execute and try to find known bugs. Let's try this out, actually. Let's try it. So if I turn this off, so Jazzer.js will keep track of previously found bugs. So I did find and execute that error state before. So Jazzer.js kind of keeps track of that. So if I run this again, npm fuzz, run, and look, it takes a few seconds. But you can see already it's passing. You can already see that it's already found that regression case with the awesome fuzzing string and decided that, yes, this has been fixed. And so we don't have to try this again. So it will continue fuzzing. I saved everything. Yeah. Okay. So continue fuzzing. And we're going to do this. So that's regression mode, where you are trying to locate known issues and verify that they're no longer present. So that's a fun feature. Very helpful if you're trying to do things in continuous integration. So you may, as a single developer, if you're interested in AppSec, you might fuzz for a minute, 10 minutes, 8 hours, however long you have, to try to find all those nasty bugs. But in CI, you don't want your CI pipeline to take 8 hours. You want it to go as fast as possible, so you can enable regression testing to verify that known bugs have not reappeared. So that's a fun feature. And I think that might be it. Oh, one other thing actually I do want to show is, so it's also possible, so this is a data buffer. So part of the reason we defined this function to take, to take this as a buffer is that, so a buffer is very generic data type. It's just a bunch of bytes. So what if you have a function that specifically takes or requires a string, or specifically requires number values, or decimal values, or floats? You can also access that as well. So there is a construct known as a fuzzed data provider. So for example, like number data. So actually, yeah, let's call it number data. So you can basically create this object. I guess I'll call it an object. I never know in JavaScript. I'll create this object based on this data, this data object that the fuzzer creates. And then once I have this number data, I can access things like, possible to get, I'm blanking. It's called like generate. Or something. But through this data provider, you can access strings. If you're interested in ASCII strings only, or if you're interested in alphanumeric values, you can do that kind of thing as well. In this case, it's good enough to just pass in a data buffer, and it'll just find some interesting cases. But you might want something a little more finer grained in terms of types. So yeah, that's it. That's it for this. So all of this code is available on the GitHub link that was shared earlier. Yeah, I'm happy to take questions or have a chat about any of this. Feel free to roast me in my JavaScript skills. But yeah, thank you very much. This was a fun presentation.